this is day 126. We're going to talk about inverse functions, and we're going to find the inverse of all functions, whatever they are, and then we're also going to talk about piecewise functions. So I've actually taught you some of this before. Now it's going to be an official lesson because I want to make sure you got it. Inverse function is real simple. You know how there's an y is equal to something x plus 3 or whatever? You all know what I'm talking about? All we're doing with an inverse function is we're saying, hey, we're going to flip around the x and the y and make it a new equation. And so we're going to talk about inverse operations. So what's the inverse of adding? What's the inverse of multiplying? Good. What's the inverse of squaring something? Good. What's the inverse of the fifth root of something then?
Oh, putting it to the fifth power.
That's right, putting it to the fifth power. Okay, that's right.
Whatever.
Okay, so you just have to know that. It's going to take a little bit of algebra. And we're switching x and y, okay? So remember from geometry, the term reflection. Remember that? Okay, so we're trying to connect that. So visually you could think of inverses like a reflection. So this is the line x is equal to y. And I could also think of this as y is equal to x. I could flip these around, okay? But remember in geometry, let's say you had a figure, like let's say there was a triangle here. I could reflect this across, right? Can I reflect this across this line? I could just change all the x points and make them y points. And then you got a new reflection, okay? Does that make sense? Okay, so that's the visual connection. That's the concept. We're trying to reflect the graph. But we're going to work on this algebraically today, or we're going to switch x and y around, okay? It can, but we're talking specifically reflecting across this x is equal to y equation. Okay? So that's a good question. It's not across the x-axis. On this one we're going to do directly across this line. Okay? So if you're in the video, please pause it and write this down. Okay. Here we go. Derive the inverse of the function. So number 1, okay, and 2. I'm going to show you how to do a couple of these. You can watch. This is all going to be algebra. So we have this function notation, f of n. That's just the name of this function, okay? F of n is equal to 1/3 n minus 2/3. So whenever you see function notation like f of n or f of x, all you got to do is just assume that's a y, okay? Whenever you see that, just assume it's a y. And whenever you see a letter that's like f of n, just assume it's an x, okay? So let's just make it x and y for the sake of simplicity, okay? This doesn't change what it is at all, okay? It's still a function. So now we're going to find the inverse. Ready? So this is the original. Eyes up here. This is a real simple concept, but if we don't get it, you're not going to, you won't keep it. So we have y and x. All we're going to do is switch the y and the x around. Watch me. I'm going to change this y to an x, and then we're going to change this x to a y. And we're just going to bring all the other numbers around it, okay? So now we have a new function here, but we want it so that it's equal to y, okay? Is y isolated right now? No, it's not. So I'm going to isolate it. So I'm going to add, I notice that it's all this, it says 1/3 y minus 2/3 is equal to x. So I'm going to add 2/3 to both sides. And when I do that, I get x plus 2/3 on the left side. Or 2/3 plus x is fine, it's commutative, is equal to 1/3 y. Okay? This is like saying 1/3 times y. So now I have to think about the inverse operation. What's the opposite or inverse of multiplying by 1/3? Divide by 1/3. And when I divide a fraction, I know I'm really multiplying by the reciprocal. So I'm going to multiply both sides by the reciprocal. And when I do that, I got 3 times 2/3. It's 3 times 2 is 6. And then it's 3 over 1, so 1 times 3 is 3. So 6 over 3 is actually 2. Okay? On the right side, the 3's cancel out and the 1's cancel out, which is equal to y. Over here we said it's 2. 3 over 1 times positive x is positive 3x. And now my y is isolated, so I'm going to use the symmetric property and just change the side so it looks neater. Okay, that's all I'm doing. Okay, but I originally didn't start with y and x. What did I start with? I started with f of n and n, right? So n is really my x. F of n should be my y, but this is not my original y. This is my inverse, okay? So watch this. When I want to write an inverse in math, I identify it by f to the negative 1 of n. Okay? F to the negative 1 of n is equal to 2 plus 3n. Okay? What this is saying in math is that this function is the inverse of the original function. Does that make sense? Okay, that's all we're doing. This is the goal for today, or one goal. Questions on number 1? Yes, sir.
The 3 over 1 on the left side, so you just cancel out the 3's and then multiply it by 1.
Yeah, like 3 times 2 is 6, right? 1 times 3 is 3. So what's 6 over 3? 2. Does that make sense? But then we have to do this is distributive property. We have to do 3 over 1 times positive x. It's just 3x. Right? Yeah.
Could you go from x equals 1/3 to y minus 2/3 to the bottom?
Which step are you at?
Relatively.
Right here? What's your question again?
Could you redo it?
All of it?
Just the part where you go down.
Oh, okay. So you see how y is not isolated? So I'm going to isolate. So I'm going to, this is being multiplied by 1/3 and y is being subtracted by 2/3. I'm going to add 2/3 to both sides first. Okay, which the 2/3 plus the x is equal to 1/3 y. Y'all see that? And then I multiply both sides by 3 over 1. That's the reciprocal 1/3. Okay, so that's number 1. This is the inverse. So whenever you want to write an inverse, or you see this word f to the negative 1 of n, the negative 1 after the f is called the inverse. Okay? Y'all good? Okay, let's do number 2. Ready? Number 2, I'll go a little bit more quickly. We got f of n is equal to the 5th root of n plus 2 all minus 1. So watch this. I'm going to change my f of n to a y, and then I'm going to change my n to an x. Okay? That's the first step, just so it makes sense to me in my mind. Second step, I'm going to get the inverse now. I'm going to change my x to a y and y to an x. Okay? So we're going to change this problem to the inverse. And just by doing that, this is already an inverse function. So now we're going to solve for y. So how do I get y by itself? Well, I got this 5th root of y plus 2. This is a package, and then all of that's being subtracted by 1. So I'm going to do the opposite of subtract 1, which is add 1 to both sides. So I'll get x plus 1 is equal to the 5th root of y plus 2. Okay? And then, remember earlier, what's the opposite or inverse of the 5th root of something?
The power.
The 5th power. So I'm going to take both sides, raise it to the 5th power, okay? So it's going to be x plus 1 all to the 5th power is equal to, the 5's cancel each other out, so all I'm left with is y plus 2. Subtract 2 on both sides. I get x plus 1 to the 5th minus 2 is equal to y, and then I'm just going to make it look a little neater, start with the y, okay? So, but that's not what I originally started with. The y is actually our inverse function, right? So now I'm going to start with what I had f of n as my original function. Now we're talking about the inverse of f of n, which will be f to the negative 1 of n is equal to, and x wasn't the original variable. We're going to change x to n, so it's going to be n plus 1 to the 5th, all minus 2, and then that's it. Okay? And if you graph these, if you graph the original function and the inverse function, you're going to notice a reflection across that line, the x equals to y. Okay? Questions on numbers 1 or 2? Yes?
So you know how you had the red and then you just got rid of the
Yeah, the 5th
Why
root.
did you get rid of the...
Because I needed to get relieved or release the y plus 2.
But
So
you can only do that if you have like you can cancel out, right?
yeah, you have to do the inverse function or the inverse operation. Okay? This isn't too hard once we get used to our inverse operations. Okay, so since today's Monday, let's have this people on the video pause here. Okay, number 3, we're going to do this together. So number 3, please write it down. G of x is equal to negative 5x plus 25. Okay? Okay, here we go, number 3. So first step, let's all take g of x and let's just rewrite it And let's just change g of x to x, okay? Because we're going to do that anyways, right? We're getting the inverse. If g of x is equal to y, let's change it to x. And let's change our x to a y. Okay, we're finding the inverse. That's the first step. Okay? Okay, now turn to your neighbors. Tell them what strategy you would use to isolate the y variable. What strategy would you use? Okay, what would you do to isolate the y variable, everyone? Okay, good. So we're going to subtract 25 on both sides, and we got is equal to negative 5y, which is like saying negative 5 times y, right? So what's the opposite of multiplying by negative 5? Good. We're going to divide by negative 5 on both sides, okay? Now watch carefully here. So what's x divided by negative 5?
X divided by negative 5 is x over negative 5.
X over negative 5. Or here's another thing. What's the imaginary, or what number do we assume is out here in front of the x? 1. So let's think about it this way. What's 1 divided by negative 5? Negative 1/5, right? And then we have that x we could put right after. Do y'all see that? This is a more appropriate way to find that, okay? Then we do the next number. We got negative 25 divided by negative 5 is?
5.
Positive or negative 5?
Positive.
Good, so we're going to write positive 5. Remember, we're doing this together. We're not checking out right now. Positive 5, okay? Exactly. You're writing this down? Okay, please, we're doing this together. Thank you. Okay? Is this making sense so far? Okay, cool. So now we have to switch sides. We got y is equal to this value. So remember, y wasn't our original variable we used. We actually used g of x, right? So let's change our y to g of x. And this is not just our g of x. This is our inverse function g of x. So I'm going to write g of to the negative 1 of x. And then we're going to use the symmetric property. We're going to bring that negative 1/5 x over. And plus 5, and then we're all done, okay? Yes, sir?
Is the negative 1 what flips it onto a different side, like on Desmos, if you were to put that in? Like, you know, you did the triangle?
Yeah, on Desmos, I'm not sure if it does that. Let's do some exploring, because I think they're adding new features every day, so it might work, yeah. The big idea here, though, everyone, is that this is the original function g of x, and when you have g to the negative 1 of x, you're saying this is the inverse of the original. This is also the inverse of this one. It goes both ways. Okay? And let's do that, actually. That's a great question. Let's go to Desmos. Students, okay, continuing on. Number 4. I'd like you to try number 4. We got h of x is equal to 2 over x minus 2. We are doing this by ourselves right now in our notebooks. This is the last problem before we move to the next section of our lesson. Okay? Go. Okay, so this one, would you all agree to first switch your x and your y?
Yeah.
Did you all do that?
Yeah.
Okay, good. Would you all agree to add 2 to both sides first?
Yeah.
Okay, so how do you get rid of this y in the denominator?
Multiply
Multiply
2 on both
2.
sides.
Why would you multiply by 2?
Because
Because it's dividing.
Okay, this one's a tricky one. You notice how y is being divided on one side? What's the opposite of dividing by y? So you should be multiplying by y on both sides. Right? Does that make sense? And then it's all equal to 2? So that one's a tricky one. When y is being divided, or the variable is being divided, you have to multiply by that variable. Okay? Now how do you get y by itself? If y is being multiplied by x plus 2, how do you get y by itself?
Divide.
Good, we're going to divide by x plus 2. So we got 2 over x plus 2. Okay, this is a valid answer here, but let's keep going here. What's 2 divided by x? What's 2 divided by x, everyone?
2 over x.
2 over x, good. Then we have to do it again. What's 2 divided by 2? What's 2 divided by 2? 1. Okay, good. So it's positive 1. So here is 2 valid answers. I would take these 2, and then of course you have to put your function notation, which is going to be the inverse of h of x is equal to 2 over x plus 1. Okay? Good? No? Someone shaking his head. Where are you getting lost?
No, I see what I did. I was going to write it.
I'm sorry?
I see what I did. I was going to write it.
Oh, okay, cool. I'm going to pause the video here for a moment. Write this down if you got it wrong. That was the first part of the lesson is inverse functions. I know I've taught this before, but I want to make sure you see that. The big idea is you're switching the x and the y. Inverse functions, you just switch the x and the y, okay? And it looks like a reflection when you graph it across x equals to y. Okay, second, now we're going to talk about piecewise functions. We've done these before in Algebra 1. Okay, piecewise functions are a combination of different functions with a rule, okay? It's going to look crazier than it is, and it's really not. You just got to go slow, and you'll see that it's going to look like a kind of like a roller coaster, okay? So, here we go. Number 5, okay? Number 5. So, iPad's down right now. Everyone's looking up here. I'll show you number 5, just one, and then you're going to do number 6, okay? Thanks. So, on number 5, we got this function, which is actually two separate functions, you see here? But the functions have rules. It says, use this rule, negative 2x minus 1. Use this function when on the graph where x is less than or equal to 2. And what that means is you see how the x-axis has the number 2 right here? All we're going to do is put a vertical line. Whatever is less than or equal to 2, we're going to use this first function, okay? The second function right here, we're going to use it when x is greater than 2. So we're going to use the second function to the right of this line. Does that make sense so far? Okay, so watch me do the first part of number 5, okay? So I'm going to focus on this first one. Ready? What kind of graph is negative 2x minus 1? Linear, quadratic, exponential, absolute value, cubic? What is it, everyone? Linear, right? Doesn't it look like y equals mx plus b? Do y'all see that? So what's my y-intercept, everyone?
Negative 1.
Negative 1, okay? So I'm going to go to negative 1. I plotted a point here. What's my slope here on this first one?
Negative 2.
Negative 2 over 1, right? So watch this. I'm going to go down 2 over 1, plot a point. Down 2 over 1, plot a point. Down 2 over 1, plot a point, okay? Now I'm going to draw my graph. Okay, and this is the graph all the way across the whole coordinate plane, right? But doesn't it give me a rule? Look at my rule. What does it say? Only graph this where x is less than 2. So if I were to look at the x-axis, I only want to keep the blue graph where it's less than 2. Do you all see that? So I want to erase this part right here down here. So I'm going to erase it. Okay? You all see how I just erased it right there?
Yeah.
Okay? And it says we want to keep this graph so that it's less than or equal to 2. So it's going to go forever to the left, but it's also going to be equal to 2. So watch this carefully. Here's a rule. We're going to take a circle at the end of where it's supposed to stop. And since it's equal to 2, I'm going to fill this circle in. Okay? And then I know it goes forever to the left. There is no restriction going that way. So that's the first one, okay? This will be my blue graph, and I'll underline it as blue. Okay? Second graph. I'll use a different color. I'll use red this time, okay? What kind of graph is negative x plus 4?
Same one.
Same one, right? What's my y-intercept? 4, good. So I'm going to go up to 4. What's my slope? Negative 1, good. So I'm going to plot some points for my slope. And in the same manner, I'm going to graph this. Now, look at the rule. What does it say? X has to be what? Greater than 2. So when I go to greater than 2, you see how there's some line that I should be getting rid of right there? So watch this. I'm just going to get rid of it. I'm going to erase it. And I'm going to put a circle around. Just with my iPad. Okay? So you notice how I put a circle here? Now look, does it include it? Is there an equal sign there? No. So that means that we're just going to leave the circle open. Okay? So a piecewise function is a set of different functions with a rule. So this blue one starts and only goes up to 2 on x is equal to 2, right to here. And then once you get to 2, it's going to include it. And then after 2, immediately after 2, it's going to jump back up to here and start going down again. That's the rule for this piecewise function. This is all one function. Yes?
How do you know, like, where to cut off, like?
By the rule here. So you see how it says x is equal to 2? Look at the x-axis. You see how it says 2 here? So that means you're looking from left to right. I want to include everything to the left or less than 2 for the blue function. and everything greater than 2 for the red function.
Oh, so which way the sign is facing?
Exactly. You have to think less than greater than. Good question. Okay. So this is a couple of different functions. These are linear, so they're easier. But you could combine linear, absolute value, quadratic. You could do any type, okay? And these are used in real life a ton because when you have different inputs, you might have a different rule for that input. Okay, so 2s, remember I said the 2s are going to talk. The 2s are going to talk to their group about how I just graphed number 5, okay? Ready, set, go. We'll do number 6 together. So take a moment. You're going to make a rough X and Y axis, okay? And now you see there's 3 functions up here in this one piecewise function, okay? Can you click the iPad off so we're not distracted? I'd like to get through this, please, okay? And then after, you could look at as many pictures as you want. And maybe I'll give you an autograph.
Oh.
You're like, no. Ready? Okay, so this one's saying f of x has to be -4, meaning, remember, f of x is like saying y. It's saying y should be -4, okay? Which means I should have a horizontal line, but what does it say? What's the rule? We only want a horizontal line up until x is less than -2. So looking at -2, I'm going to have a horizontal line up to here. So y'all see that? So check this out. I'm going to make a horizontal line at -4. I don't know why I was up before here. Okay? I'm not going across the whole graph. I'm going to look at my rule. How far do I go? Up to -2. That means I need to cut this thing off or erase it up to -2. And I'm going to keep it right there, okay? And I'm going to draw a circle at the end of where I erased it. I ask myself, do I fill it? Do I need to fill this one, everyone?
Yes.
Yeah, because it's equal to. So I'm going to fill this guy in, okay? That'll be my first function, okay? Or first part of my piecewise function. So that's the red one. Now I'll switch colors on my my presentation so you can see. Okay, and the next one I'm going to use blue, okay? So this will be the next one. What kind of graph is this? Linear, good. What's my y-intercept, everyone? -2. So I'm going to go to -2. I'm going to pretend like I'm going to graph the whole thing, okay? But I'm not graphing the whole thing. It's saying, look, it's saying I want this to be x is less than 2, so I only want to go up to here. And notice that it says x, I'm going to read it backwards, x is greater than -2, so I'm only going to go to here. So I'm only going to have this little piece of a blue line, okay? I'm going to put circles at the end, and these circles are open, right? So even though the red one's filled, that's okay. The blue one is still open, but it means that this point is connected right here, okay? Continuing on, -2x plus 4. It's another linear. I'm going to plot my y-intercept. I'll use green here. And I'm going to go to +4. +4, and I'm going to go, my slope is -2 over 1, -2 over 1. So I plot a green point here, -2 over 1. I should have a line that looks like this, right? But it's the rule is saying make sure it's greater than 2. So I'm going to go to greater than 2, and I want to make sure I keep that part of the line. And then I'm filling that green part in the end of the circle. And that's it. Okay? And that's basically it. Piecewise function. Is that kind of hard?
Yeah.
It's a little hard because you have to splice them together, right? Okay, so why is this relevant? Let me tell you, like businesses look at piecewise functions all the time. They might have rules for how they run their pricing models, okay? Or they might look at their profit for certain years. So let's just say we're at year 0, right here. Let's say we're at year 0. We're looking back. 2 years ago, were we making money? If we're looking at the graph? No, we weren't making money for a long time, right? From -8 to -2 years, we're making no money. How long ago did we start making money? 2 years ago, right? How far ahead do we forecast to keep making money? How many more years? 2. What's going to happen in 2 years to our profits? That's going to drop. Does that make sense? So businesses actually use piecewise functions to make predictions or to make forecasts or to talk about the story of what happened in the past, okay? Or they might say, hey, this is, if we have, well, we can make up a story about anything. And we could move the x's and y's around and we could create any profit and loss, okay? All right, that's it. That concludes the lesson. Sorry, that was a long lesson.